All right. So question number one, let's go ahead and take care of it. Some of you did it correctly, but not the way that you should have done it. So let's read it. It says the function g is differentiable and the tangent line to the graph of y equals g of x at x equals -1 is y equals 2x minus 3. This is a tangent line, guys. This is not g of x. So g of x does not equal 2x minus 3. It just so happens when you have a tangent line and when you have a curve, they have a lot of attributes that are the same. So what are the same? The point of tangency is the same, and then, well, you can see here, so your slope, so this is your tangent line, so that means that g prime of -1 is in fact 2. And remember, the curve and the tangent line share the same x and y coordinates. So if I plug in a -1 in here into your tangent line, you're going to get g of 1. So let's see, y equals 2 times -1 minus 3. So -2 minus 3, so -5. G of -1 is -5 because the tangent line and the curve share that same point. Does that make sense, guys? Okay, so now that we did that, let's go ahead and take the derivative of this. I'm going to write f prime of x equals, and then just do chain rule, -6 bracket g of x, only to have the, have it look the same like that. Subtract 1 from that 2, so there it is, and then times chain rule, so times the derivative of the inside, g prime of x plus 2. Are we okay so far? All right, so then I'm just going to plug in a 1, f prime, or -1, -6 bracket g of -1 times g prime of -1 plus 2. If you did this, you at least got 1 point. Actually, if you did the top line, you got 1 point and it cannot be taken away. Even if you circled the wrong answer, you got 1 point there. Okay, now we're just going to plug in -6. G of -1 is -5. And then g prime of -1 is 2 plus 2. So -6 times -5, that is a positive 30. 30 times 2 is, and 60 plus 2? 62.
Yes.
Yeah. There's at least 2 of you that had like a -60 and then you added 2 and then you said, well, I guess I'll turn that -60 into a 60. I couldn't give you full credit because of that, but I did give you at least a point for if you had something that was correct. What's up?
Are you able to explain one more time on how g prime of -1 is 2?
Yes. You see how they told you the tangent line? What's the slope of that tangent line? 2. And every time you're looking for a tangent line, what 2 things do you need? Point and a slope. So that means the slope of g at -1 has to be whatever the slope of the tangent line is. So it would be ideal if you did this on the side somewhere, and you did that. But some of you told me flat out that g of x was 2x minus 3. G of x was not 2x minus 3. We got lucky because of the properties between tangent lines and the curves. If this were a free response question, guys, you would probably be docked points. I hope that maybe they would give you a point for like the first step, but this is like, does everyone know that 2x minus 3 is not g of x? Okay, so let's try not to do that. All right, question number 2. It was implicit. Do not write f prime of x and then take the derivative of it. Just take the derivative with respect to x right off the bat. So what's the derivative of 3x squared with respect to x? 6x. So what's the derivative of 2y squared? 4y, and then that's not an x, so dy dx, perfect, equals the derivative of 14 is 0. And then some of you are factoring out the 2. That's fine. It's not a big deal. I group the 2 with the x, so I go first times derivative of the second. Perfect. Plus second, and then derivative of the first. The derivative of 2x is 2, and then don't forget that minus x. So one of you forgot about that minus x. I still give you a point, but I was just trying to give you points wherever I could. And then what's the derivative of x? Yeah, you can say -1 because it says minus x. And there it is. And if you did that, you got a point no matter what, no matter if you chose the wrong one. I gave you a point no matter what, if you did that. Now it just turns into algebra, just algebra. So I'm going to move the 2x dy dx into the left, and I'm going to move the 6x to the right. So 4y dy dx, bless you, minus 2x dy dx equals, let's see, I'm going to write the 2y first because it's positive, and then I'm going to write minus 6x minus 1. It's okay if you write -6x plus 2y. It's the same thing. Now I'm going to factor out a dy dx, bless you squared. 4y minus 2x equals 2y minus 6x minus 1. Perfect. Then you're going to divide to get the dy dx by itself. 2y minus 6x minus 1 over 4y minus 2x. And then some of you, which is fine for now, I gave you full credit. Some of you continued there and then you just put the numbers. I would like for you to do a new line, but it's okay if you did it here. Start a new line. Just go dy dx evaluated at, perfect, -1 comma 2 equals. So I'm just going to plug in. So it says y there. What's 2 times 2? 4. And then -6 times -1. +6 minus 1 all over 4 times 2. 8. And then -2 times -1 plus 2. So let's see. 4 plus 6 is 10. Minus 1 is 9. 8 plus 2 is 10. So there is my slope. And now all you do is point slope formula. So here it is. Y minus 2 equals 9 over 10 parenthesis x plus 1. There was at least one of you that got to here and did not get the correct answer. I gave you 2 out of the 3. You were so close. Keep going. All you have to do is make it look like this. Make the x's and the y's on the left. So here's what you do. And you could, I'll just do it right here. I think this is what's easier for you guys. Distribute that. Y minus 2 equals 9 over 10x plus 9 over 10. So catch up to there. Does that make sense so far? And multiply everything by 10. If you multiply everything by 10, chop, why did you choose 10? Because I see a 10 in the denominator down there. And look, none of these are in fraction. Do you guys see that? So that's the logic. Multiply by 10. So then you get this. 10y minus 20 equals 9x plus 9. And then last move the 20 to the right. So you're going to add 20 and move the 9x to the left. So here we go. I'm gonna write the 10y first because that's positive. 10y minus 9x equals 29. And let me put a little, and I look for that. And the answer is D. Maybe I could have left more room for you guys, but it didn't take up too much more. If you wrote small, you could fit it all in there. Okay, we're okay? Question 3. Don't worry, guys. We'll be done after question 5, and then we'll call it a day. So you have an F here. So you have the point -4 comma 2 on F, and then you have the point 2 comma -3 on F, and they're giving you the derivative at 4 and the derivative at 3, and they want the derivative of the inverse at 2. So you should focus on that one there. So because that 2 was a y value on F. You guys see that? So I need, and some of you did a table, which I think is awesome. So maybe we're nice because this one didn't help at all. So we need f prime of -4. Do I have f prime of -4? There it is. That's 5. So if that's 5, what is this? The inverse derivative at 2? 1/5. Here we go. The famous 2 last questions. No, I can tell who's been practicing because you guys did at least the model. The hardest part about these 2 questions, why are these harder than the questions on the AP exam? Because the model. I would say 95% of the time, the AP exam will give you the model. I have seen a question that wants an optimization where you have to create the model, but those are very few. If you miss those questions on the AP exam, you can still get your 5. So here it is. So let's see. Find the largest possible area for the rectangle with bases on the x-axis with upper vertices on the curve 1 minus x squared. All right. So hopefully everyone can do y equals 1 minus x squared without a calculator. The vertex is at 1 and it's symmetric on the y-axis. This is just like y equals -x squared moved up, shifted up 1. So it looks like this. That's how it looks. Look, you know how y equals -x squared looks like. If I add 1 to it, that's the same thing as that. It just moves up 1. This is 1 up here. Here's my rectangle. Because it has to be inside that parabola there. And some of you were so close, you had like the right picture, but you couldn't figure out the model. The distance from the x-axis to the blue line, this is just some x. Notice that's just half of it. So what is the entire distance? This in purple. What is that entire distance? 2x. Do you guys see that? And then the height. Oh, you said no? Oh, you got it? No? Oh, no, but you got some points, Miss. I graded yours already. Because you had the right idea. So the distance, the whole distance on the bottom is 2x. Does everyone see that? And then the height is y, and y is dictated by this curve. Y equals 1 minus x squared. So the area for this is 2x times 1 minus x. Well, I guess first let's do 2x times y. 2x times y. Do you guys see that? And then if I replace everything in terms of x, my area is 2x times 1 minus x squared. Are we still okay? Okay. This is what I want to optimize. See, it says largest area. So whatever you want to optimize, that's what you want to take a derivative. Distribute. So 2x minus 2x squared. There it is. That's my area formula. This is what I want to maximize. Take a derivative. A prime. What's the derivative of 2x? What's the derivative of 2x squared? I'm going to equal that to 0. Let me make sure that I'm doing, no, 2. Yeah, 2x cubed. Yeah, sorry. I think I heard someone say 4x and then I wrote it. I think we're good now. Let me see, 2x. Yeah. Yeah, I distributed. 2x times 1 is 2x. 2x times x squared is 2x cubed. So I haven't taken the derivative yet. Sorry, guys. 6x squared. Now everything's correct. All right, so here we go. I'm going to solve for this. 2 equals 6x squared. I don't see an issue now. Is there any issues right now? Okay, divide by 6. 1/3 equals x squared. Are we still okay? How do I get rid of that x squared? Square root. X equals 1 over square root of 3. Because square root of 1 is 1, square root of 3 is square root of 3. I'm going to multiply this already by square root of 3 over square root of 3. So square root of 3 over 3. Are we still okay? All right. Is this a max? Well, if I do a number line for a prime, and I start at 0, and I put here square root of 3 over 3, if I pick a number like 1, yeah, let's see. If I pick a number like, I'm going to pick a number like 0, because 1 is actually bigger than square root of 3 over 3. If I pick a number like 0, notice that 0 squared is 0, and 2 minus 0 is positive. If I pick a number like 1, which is bigger than square root of 3 over 3, 2 minus 6 is negative. So if I go from positive to negative, if a prime goes from positive to negative, that means that a must have a max. So I have a max here. Max a has max at square root of 3 over 3. Man. All right, here we go. Sorry guys, I'm on fumes right now, as in like very little sleep. You don't have to do that. Yeah, it's if you get a critical number with restrictions of, then that one critical number has to be a max. So you don't have to show me this. You could just gone right into, which at least a handful of you did do. So area equals, this is already an x, guys. You can just plug it in right here. So 2 times square root of 3 over 3 minus 2 times square root of 3 over 3 cubed. Chop, how are you going to get an answer from that? It's just arithmetic. Chop, I need a calculator. Look, let's go slow. 2 times square root of 3 over 3, that's 2 square root of 3 over 3. Are we still okay? Minus 2, open parenthesis. All right, let's analyze the inside. Square root of 3 times square root of 3 times square root of 3 is going to be 3 square root of 3. 3 times 3 times 3 in the denominator. 27, right? 3 times 3 is 9. 9 times 3 is 27. How many times does 3 go into 27? So scratch out the 3, turn the 27 into a 9. Are we still okay? All right, so here's where we're at. 2 square root of 3 over 3 minus 2 square root of 3 over 9. I'm going to multiply the first term, the 2 square root of 3 over 3, by 3 over 3 to get a common denominator of 9. What's 2 times 3? So now I have 6 square root of 3 minus 2 square root of 3 all over 9. What's 6 minus 2? 4 square root of 3 over 9. We're still okay, guys? Okay. Now, some of you had the right idea. If I put in there right idea, I gave you a point. And if I didn't give you a point, let me know before you leave. So maybe you should see your test before you leave. Are we still okay? All right. Last one. After question 5, the rest are just normal questions from AP. So question 5 was the last UH question. You all ready? The figure to the right shows a region that consists of a semicircle on top of a rectangle. Give the value of x that maximizes the area of the region of the circumference if of the region is 6. Oh, it should say if, but I just didn't type it correctly. All right, only 2 of you asked me throughout the whole time about this question. Maybe you saw it in the video, which is fine. But by coincidence, I don't remember. I would have to look at it. But I think like 4 of you had the right idea, and then everyone else, I don't know. So, guys, let's talk about it. Let's see. So the perimeter of all this is 6, right? So I'm gonna go ahead and write. Let's see. What am I gonna write? This vertical displacement here. I'm gonna write that as y. And I know that circumference of a circle is 2 pi r, but I don't have a full circle. I have how much? Half. So I'm going to divide that by 2. Are we still okay? All right. Perimeter. Perimeter is 1x, which is this one right here, plus how many y's do you see? 2 y's, plus, and then half of the circumference, this in blue right here. The radius of that in blue is this distance. And that is half of x. So plus pi, parenthesis, my radius, I'm going to write it as x over 2. Close it. Let's see. I want to make sure that everything is correct. I forgot the what? Well, circumference is 2 pi r. So, right, from 1 revolution is 2 pi radians. So circumference is 2 pi r. Yeah, they're not going to give you formulas, guys. Not for those. They're not going to give you the area formula and circumference formula and area of a rectangle, area of a square. Stuff like that, they're not going to give you. They will give you area of a cone, volume of a sphere, but not the common ones like that, guys. All right, next. What else do I need? They want me to maximize what? The area. Okay, so here we go. Area. Area equals, how do I get area of this rectangle right here? X times y. Plus area of this half a circle. So area of a circle is pi r squared, but I got to divide that by 2. So here's what I have. Let's see. xy plus pi parenthesis. My radius is x over 2. You can say half x if you want. Divided by 2. Square it and divide it by 2. So here we go. I'm going to write xy. Don't worry. In a little bit, we'll replace the y. Plus pi, and I'm going to go slow. I wanted to take shortcuts, but I better not. What's x times x? X squared. What's 2 squared? 4. And remember, this is still divided by 2. So my area formula is xy, which I'll replace the y in a little bit, plus pi. And then what's 4 times 2? So this is 8. Does everyone see how I got that 8 down there? Yeah, it's like keep, change, flip. All right, this is what I want to maximize, so this is what I'm going to take a derivative, but I can't take a derivative because there's a y at the moment. So I use this right here. What did they tell me the perimeter was? I use that as a restriction. Do you guys see that? So here we go. I'm going to write, on the side, I'm going to go ahead and write, let's see, I'm going to write x plus 2y plus, I'm going to write it as x pi over 2 equals 6. This is my perimeter. That's that right there. And all I'm doing is solving for y. So I'm going to move the x to the right and I'm going to divide by 2. So I'm going to write 2y equals 6, and I'm going to move this one to the right as well. 6 minus x pi over 2. Are we still okay? All right. Divide by 2, divide by 2, divide by 2, divide by 2. So here's what I see. Y equals 3 minus x over 2 minus x pi over 4. Plug that into this area formula. Area equals, now let me slow down. x parenthesis 3. Oh, wait. Yeah, because this is my y right here. 3 minus x over 2 minus x pi over 4, close it, plus pi x squared over 8.
Why did you put on X?
I put it in for y. See, this is y right there. xy plus.
Okay.
Yeah. I'm just going to distribute. So let me change the color so it doesn't bleed into those lines. 3x minus x squared over 2. Are we still okay, guys? Minus x squared pi over 4 plus pi x squared over 8.
So would it be like 2 pi X?
Yeah, in a little bit it will. All right, here we go. Taking the derivative. We're almost done. This is as hard as it gets. What's the derivative of 3x? 3 minus what's the derivative of x squared over 2? Oh, which over 2, which is just going to be negative x. Minus, when I take the derivative, pi over 4 is a constant. So when I take the derivative of x squared pi over 4, that's going to be 2x pi over 4, which is x pi over 2. Does everyone see that? Plus, let's make sure we're correct. I don't see any mistakes. Let me make sure. Yeah, we're good. 2 pi x over 8, which reduces to pi x over 4. Maybe I should have left it as over 4, the other one, but oh well. Are we still okay? All right, I'm going to go ahead and multiply this one here by 2 over 2. So I can combine these last two down here. 3 minus x minus 2x pi over 4 plus pi x over 4. I'm trying to go slow, guys. I'm trying to show every step here. 3 minus x minus, and this is all just 1 now. So let's see. So I'm going to put the minus 2x pi plus pi x, bless you, over 4. Yeah, so you guys can see it. It's the same thing here. So I'll put x pi instead. Negative 2x pi plus x pi. What's that? Negative x pi. 3 minus x minus x pi over 4. And since this is my derivative, this is going to equal to, bless you, 0. And all I'm going to do is solve for x. Move the 3 to the other side. So let me see. I can still fit it right here. So negative x minus x pi over 4. So in a little bit, I'll get a common denominator. Equals negative 3. Yeah, you can already see what it's going to be. You guys ready? I multiply this one right here by 4 over 4. So it is a lot of arithmetic. I want to make sure that I'm not making any mistakes here. So let's see. We have negative 4x over 4 minus x pi over 4 equals negative 3. Are we still okay? What's up? Well, I'm going slow. I am going to factor right here. Negative 4x minus x pi over 4 equals negative 3. We're still okay, guys? I'm just going really slow. You can take shortcuts. It's not a big deal. Times 4 to get rid of that 4 in the denominator. That's a semicolon for a new line. Negative 4x minus x pi equals negative 12. And here's the moment of glory. I'm going to factor out an x, semicolon. I'll write it right here. X parenthesis. Let's see. Should I factor out a negative also? Yeah, let's factor out a negative for now. Don't worry. We'll switch in a little bit. I'm factoring a negative x, guys. X plus pi. Close it. X plus, oh no, that's negative 4, sorry, 4 plus pi, close it, equals negative 12. Divide. Do you guys see it? Negative x equals negative 12 over 4 plus pi. And the last move, I don't want negative x, I just want x. So you just either divide by negative or multiply by negative, whatever you think is easier. So what do you think is easier, multiply? x equals 12 over 4 plus pi. And there it is, the first 5. Maybe we took the long route. There was definitely moments where you could have taken a shortcut somewhere. And after that, the test went back to normal. And that's it. I will finish this probably this weekend. And it's up to you. It's optional. It's up to you if you guys want to watch the overview or not. All right, guys, here we go. Let's continue. Here's question 6. It says the graph of f prime, the derivative of f is shown above between -4 and 12. On what intervals is the graph of f concave up? Well, this is just straightforward, guys. F is concave up. F is concave up if we have one of two scenarios. If we have f prime is increasing. If f prime is increasing, that means that f prime prime is positive. And that's what creates your concave up, right? Because your slopes are increasing, so that creates that. Child, what do you mean by the slopes are increasing? Well, look, if I call this f, and then I call this f prime, and I call that slope whatever that is, so -3, f prime equals -1, f prime equals 5. See, -3, -1, 5. The slopes are increasing, so which means that's what that means. F prime is increasing. That's what creates concave up, guys. So I have the graph of f prime. And I'm just looking where f prime is increasing. So I'm increasing from 2 to 5. And then I'm increasing again from 8 to 11. So there it is. Yay. All right, let's see. What do we got next? If x cosine squared y equals 1, evaluate the derivative. Okay, so we got to take the derivative implicit. You're still solving for dy dx. Solve for dy dx. So here we go, product rule. If you want to rewrite it, guys, you can. X parenthesis cosine y, there we go, close squared equals 1. And then we're just going to do product rule right here, guys. So first times derivative of the second. Derivative of the second, you're going to go 2 parenthesis cosine y. So there it is. I'm not done yet. You got to do chain rule. 2 cosine y to the power 1 times the derivative of cosine y, which is negative sine y. And then this is not an x, so I got to write dy dx next to it. Close the whole shebang. So there it is. First times derivative of the second plus second cosine squared of y times derivative of the first, which is 1. And all that equals the derivative of 1 is 0. So there it is. If you did that much, you at least got a point. All this is a product. I just see x times 2 times cosine y times negative sine y times dy dx. All that is a product, so you can rewrite this as -2, let's see, -2x cosine y sine y dy dx. Maybe you want to put the dy dx up here, that's fine. Plus cosine squared y equals 0. All right, just solve for dy dx. I'm going to move the cosine squared to the other side. So -2x cosine y sine y dy dx. Yes, there's parentheses here for the argument. I just sometimes just don't put them. Equals a negative cosine squared y. And I'm just going to divide by everything here. So dy dx equals negative cosine squared y over -2x cosine y sine y. You can if you want. It depends. Some of you did it, some of you didn't. Negative divided by negative is a positive, so you can close that out. And then I have a cosine squared y and a cosine y here. You can cancel one of those out like that. All right. Semicolon dy dx evaluated at 2 comma pi over 3. So you got to know a little bit of pre-calc. Not much, but a little bit. Cosine of pi over 3 over 2 times, let's see, 2 times 2, because that's what the x is. Times sine of pi over 3. On the unit circle, pi over 3 is right here. That's 60 degrees. It goes pi over 6, pi over 4, pi over 3. And that coordinate, the x coordinate is a half, and the y coordinate is square root of 3 over 2. So, coming back to that, let's see. Cosine of pi over 3, cosine is the x coordinate, so that's a 1/2. Over 2 times 2 is 4. And then sine of pi over 3 is square root of 3 over 2. And now let's evaluate this. I have a 2 here. 2 goes into 4 twice. So this, boom, that turns into a 2 there. So now you have 1/2 over 2 square root of 3. So that is 1 over 2 times 2 is 4. So 4 square root of 3. And there's the answer, but you don't see it in there like that. That's because they probably rationalize it. So let's rationalize it really quick. So let's multiply this by square root of 3 over square root of 3. And let's see what we got. So square root of 3 over 3 times square root of 3 times square root of 3 is 3, and 3 times 4 is 12. And there it is, guys. Yeah, maybe I should have written a little smaller. Sorry, guys. All right. Function g is the inverse of f. If f of x equals that, what is the value of g, the derivative of g at -3? And they give us a hint. All right, that is a cool hint. So that means we don't have to think too much about it. Remember, f and g are inverses. So f of x and g of x. So what that means, if I have f of 1 equals -3, that means g of -3 equals 1. So there it is. So I just got to find the derivative at 1, and whatever derivative I get, I'm just going to take the reciprocal of it, guys. So here we go. I'm going to rewrite f of x equals negative parenthesis x cubed plus 2x squared plus 6, close it to the 1/2. I just rewrote it, just some algebra. And here we go, guys. F prime of x equals, so bring that half to the front, -1/2. X cubed plus 2x squared plus 6, close it to the -1/2 because you subtract 1 from the 1/2 there. And then you got to take the derivative of the inside, so chain rule, right, guys? Derivative of x cubed is 3x squared plus 4x. There it is. Now we're just going to do algebra, guys. Nothing extreme, just some algebra. So algebra is what's going to hurt us, so make sure that you got your algebra under control. There's that negative. It's this negative right there. And then I'm going to write 3x squared plus 4x in the numerator. One of you put that negative with the 3 there, guys, so be careful. Either distribute it or put it there, nice and far away so you don't get confused there. 2, and then that's -1/2, so that means square root of x cubed plus 2x squared plus 6. All right, now we're ready. F prime of 1 equals, because that was, yep. So f prime of 1, negative on the outside, and then let's see. 1 squared is 1, 1 times 3 is 3, and 4 times 1 is 4. 4 plus 3, 4. 5, 6, 7, that's a 7. Over, and then 2 times, let's see, 1 cubed is 1, and then 1 squared is 1, so then 1 plus 2 plus 6, 6, 7, 8, 9. The square root of 9 is 3. So there it is, so a -7, 6. So I'm going to write right here, f prime of 1 equals a -7, 6. So hence, g prime of -3, all you got to do is take the reciprocal of that, guys, is a -6, 7. 6, 7, 6, 7. Okay, LOL. So -6 over 7. I didn't do that on purpose. It just came out that way. Sorry if you guys are tired of that whole 6, 7 phrase. But there it is, guys. Nothing crazy. I think it's pretty straightforward. Remember, if you don't know what I'm talking about when I say take the reciprocal, then that means you don't have a good grasp of what an inverse is. Remember, when you reflect across the line y equals x, your coordinate AB turns to BA on the other side. And then remember, if you have a slope, remember the slope is change in y over change in x. But when you take the reciprocal, it's going to be change in x over change in y with respect to the original. Of course, with respect to the inverse, it's still change in y over change in x. Why is that? Because it reflects across the line y equals x. So that's how you usually find an inverse, right? You switch your x and y, and then you solve again if you wanted to find the inverse function. So there it is, guys. I'm not doing a lesson on that, but if you need a lesson on that, hit me up. Next question, guys. It says the graph of the function f and g are shown above. There's something going on with that g there. I'll look into that in the future. I think maybe by accident I shrunk that. The value of limit as x approaches 1 of f of g of x is, so remember how to evaluate these. You first evaluate the inside. Limit as x approaches 1 for g of x. So if I approach 1, here's g. If I approach 1 for g of x, that's 2, guys. And now what I'm going to do is I'm going to write limit as x approaches 2 for f of x. As long as we're continuous, we can use these properties. So, okay. I know you're about to say, Chop, that's not continuous there. I'm talking about this one, but I guess you could have also had a circle there too. But this is how it works. I guess you could have also just done f of 1. So yeah, there it is. Some of you guys chose that 1 there. So if I approach 2 for this limit, that's a 3. And as long as I don't have like a jump or the vertical asymptote right at 2, then we're good to use this. That's what I meant. And there it is, guys. It's just 3. Make sure we're pretty good at those. I love this question because this question is, you don't really have to do any real work. You just gotta understand what we're doing, or I guess understand like the critical analysis of f prime, f double prime. The twice differential function f is shown below in the domain -99. The function f has points of inflection where you see the small green circles in the graph. Determine what could be said about the values of f of -4, f prime of -4, and f double prime of -4, or a second derivative at -4. So here's -4, guys, and this graph is f. So I'm going to write f of -4 is simply 3, which is a positive number. So far, so good. And then f prime of -4, well, I notice that is, I have a horizontal tangent there. So f prime of -4 is 0. And then if I take another derivative, f prime prime of -4, with respect to f, that tells you the concavity. So I don't know the number, but I know that f is concave down. So because f is concave down, that means my second derivative has to be negative. So I'm just going to write less than 0. So in math, the smaller the number, the more negative you are, you're smaller. And then the bigger the positive number it is, well, the bigger that you are. So there we go. So let's see. This is the smallest, f prime prime of -4. And then which one else is then the next one is f prime of 4. So f prime of 4, because that one's 0. That's not positive or negative. Well, I guess technically, yeah, that's another, we'll just leave that to your number theory professor. And then that 3 there, that's a positive number. So that has to be the biggest. So f of, oh, I almost put a prime there. F of -4, and that should be a negative there. So there it is. So the smallest number is a negative one that I see, f prime prime of -4. The middle number is f prime of -4, because that's 0, or the middle value one. And then the biggest one is the one that was positive, which is that 3 there. So we look for that. Let's see, f prime prime, f prime. So it looks like it's letter F. Hopefully that made sense to you guys. I really enjoyed that question. I hope you guys did too. All right, let's see what we got here. The figure above shows the graph of f prime, the derivative of the function f, between -4 and 5. The graph of f prime has horizontal tangents at -3, -1, 1, and 4. So -3, -1, 1, and 4. Let's see. Find all values of x between -4 and 5 for which f is decreasing. Justify your answer. Okay, well, f is decreasing whenever f prime is negative, and I see that between 0 and 2. So I'm going to write f is decreasing on the interval, bracket 0, to 2, since f prime is negative on 0 to 2. Notice I didn't put parentheses here. I guess I could have put an equal sign there and then a set on this specific interval. If you put parentheses there, I guess you're not wrong, but you increase and decrease on a closed interval. They'd still give you the credit, guys, but this is, I think most mathematicians would say this is the best. So there it is. So f is decreasing on the interval 0 to 2 with brackets on them, since f prime is less than 0 on 0 to 2. Let's go to the next one. Find all values between -4 and 5, which f attains a relative max. Justify your answer. So I'm looking where the derivative changes from positive to negative, and there's only one, just that one right there. So I'll write f, and I'm just going to copy the stem. Attains a relative max at x equals 0 since f prime changes from positive to negative at x equals 0. And I know it sounds silly to say it again, but just say it again. F attains relative max at x equals 0, x equals 0 since f prime changes from positive to negative at x equals 0. And there it is. All right, find all values between -4 and 5, which the graph of f is concave up. Okay, well, I'm concave up wherever f prime is increasing. So it looks like -3 to 1, and then again from 1 to 4. So I'm going to write, and it doesn't say to justify, but it would have been nice if you did. So we gave you the credit if you just give me the intervals. F is concave up on, and then this does need parentheses. So this is just parentheses, guys. Don't put a bracket because at -3, it's a point of inflection. You're not concave up or concave down. So from -3 to -1. And if you use the union, I guess that's fine. But I'd like to just use regular English here. From 1 to 4. Since f prime is increasing on these specific intervals. All right, there it is. All right, now let's do a sketch. Given f of -4 equals -2 and 0 equals 5. And so these are just coordinates, right? So -4 comma -2. So -4 comma -2 point. I guess let me change the colors because I'm going to be graphing in red. So I'll do the blue here. 0, 5. And then 5, 8. 5, and it looks like 5, 8 is like right there. Sketch a graph of f on the x-axis. Okay. So I'm going to zoom out so I can see. Between -4 and -3, f prime is positive and decreasing. So that means, what does that mean? If f prime is positive, that means f is, that's right, it's increasing. I actually can't hear you, but I hope that you said increasing there. And because f prime is decreasing, that means f is concave down. So draw a concave down, a increasing concave down graph between -4 and -3. So increasing concave down. Doesn't have to be perfect. By the way, at -3, you have a horizontal tangent because it's touching the x-axis. F prime is touching the x-axis. You got to be specific with the words. So here we go. Increasing concave down. So increasing concave down. Increasing concave down. And then right at 3, there it is, horizontal tangent right at 3. You don't have to touch the x-axis, it don't tell you. But there it is, increasing concave down. And now between -3 and -1, f prime is positive and f prime is increasing. So that means my f better be, that's right, increasing concave up. Like I said again, I can't hear you, but hopefully you're saying that. So at -1, so I'm going to go increasing concave up until you hit -1. Increasing concave up until you hit -1. So bam. And I don't know what point I'm at. I'm just going to make some, well, okay, remember I have to hit that 5 there. So maybe don't increase so sharply, right? So let me do that again. Increasing concave up. So there we go. I'm not increasing so sharply now. I'm at some point. I don't know where I'm at, but I'm just highlighting that point because at that point, I should be changing concavities. So now from -1 to 0, I'm increasing concave down. So I should be increasing concave down. So here it is, increasing concave down. And right at x equals 0, I have a horizontal tangent. So increasing concave down. So there it is, increasing concave down, horizontal tangent right at 0, 5. Because because f prime touches the x-axis, f prime is 0 right at x equals 0. All right, between 0 and 1, I'm still concave down, but now f is decreasing because f prime is negative. So concave down, decreasing until you hit 1. So concave down, and decreasing. Concave down, decreasing until I hit 1. So there it is. There's my 1. I don't know what point I'm at. I'm just going to put a little bubble there just to indicate that I am changing concavities. I'm still decreasing, but now I'm concave up until I hit 2. At 2, I have a horizontal tangent. So let's keep going, decreasing until you hit 2. At 2, you have a horizontal tangent. And remember, you're concave up. So decreasing, concave up, and then bam, there it is. It looks kind of like a horizontal tangent before that. So let me do it again here. Come on, buddy. All right. So decreasing concave up. So decreasing concave up. Bam. There it is. There's my horizontal tangent. See? So now I'm going to be from 2 all the way to 4. I am increasing and I'm still concave up. And don't go too extreme because see, at 5, you better be at 8 there. So here it is. I'm increasing concave. Oh, let me go back to red. I'm increasing concave up. And bam, right at that moment, I better be changing concavities. I'm still increasing, but now I'm concave down. Increasing concave down. You do not have a horizontal tangent at 5, guys, because look, at 5, I'm still above the x-axis. The derivative is still above the x-axis. So increasing concave down. Increasing concave down. So increasing concave down. There it is. Increasing concave down. And I guess you can stretch it out I wouldn't actually, there it is. Perfect. No horizontal tangent. And there it is, guys. Yay, we did it. Yeah, that was pretty hard. I think only one of you got full credit on that. You got to be careful. You got to be careful with those characteristics, guys. Woo! All right, let's keep going. Oh, the bear problem. Oh, man, guys, the bear problem got you guys. All right. You're running around an elliptical track. The equation of the track is, and I know that you have this in color, so you guys couldn't really see the track, but there it is, right there around that. When you're at the point 5,2, so there you are at the point 5,2, your x-coordinate is increasing at 6 units per minute. So your x-coordinate, dx dt, is increasing at 6 units per minute. All right, no big deal. Describe how your y-coordinate is changing. Okay, so we got to take the derivative, but not with respect to x or y, but with respect to t. So here we go. I'm going to go 8x dx dt plus 25 times 2, that's a 50y dy dt. And you can actually use a calculator on this one. If we need it, we'll take it out right now. Equals 0. I don't see any issues at the moment. Let's keep going. I would probably, let's see, what would I do? Yeah, I think I would just go ahead and just plug in stuff right here, guys. Let's see, 8 times my x is 5 times my dx dt is 6 plus 50 times my y is 2, and then I'm trying to solve for the dy dt. So there it is. And now I'm just gonna do algebra, guys. Nothing crazy. I'm just gonna go. Let's see, 8 times 5 times 6. I guess I don't think it's too extreme, but we'll just take the calculator out. Not a big deal. I know what you guys are saying. You're like, child, come on, really? Not a big deal, guys. I'm not, crazy. That's well, maybe I'm crazy because that's something someone would say, right? No, I'm not crazy. 8 times 5 times 6. So look, 8 times 5 times 6. 240. Could we have done it without a calculator? Probably, but I just wanted to show that there. So this is 240 right here. Plus, and then 50 times 2, 100 dy dt equals 0. Move that 240 to the right. So we have 100 dy dt equals a negative 240. And then we'll divide that by 100. So dy dt equals negative 2.4. And that makes sense, guys, because dx dt being 6 units per minute, that means you're moving right on this right here, because you can either move right or up and down. And if you're moving right, then that means you're moving down as well, because you're on this elliptical track. See? Yay. Hopefully that made sense to you guys. Can you run in such a way that your x-coordinate changes at a constant rate? So that means, can I keep moving at 6 units per minute? Well, if you're moving around this track, eventually you're going to have to go left. See? So you can't move at a constant 6 units per minute every time, because eventually, if you're in quadrant 1, yeah, you can move dx dt is positive, but if you're in quadrant 4 and you're going clockwise, now dx dt is negative. And then if you're in quadrant 3, dx dt is negative. And then when you're in quadrant 2, dx dt is positive. When you're in quadrant 1, if you're going clockwise, it's not possible. So I'm going to say since I guess we'll start with this is a two-dimensional model and we're running clockwise. Since this is a two-dimensional model and runner is running, quote, clockwise, unquote, comma, not possible for dx dt to remain constant, i.e., that is in quadrant, let's see, in quadrant 1 and 2, dx dt will be positive. In quadrant 1 and 2, dx dt will be positive, comma, in quadrant 3 and 4, dx dt will be negative. See? I think that's a good explanation right there. All right. The inside of the track is heavily wooded and you cannot see through the woods. There is a bear standing outside the woods at the point 80. When you're at the point 52, can you see the bear? Explain. All right. So the route that I wanted you guys to do is to use a tangent line and to see where that tangent line crosses the x-axis. So think about it, guys. So, Chop, what are you talking about? If I draw a tangent line from here, let's say the tangent line looks like this, and I cross the x-axis like at 6 or at 5, then yes, you can see the bear because you can see everything to the right of that tangent line, quote unquote. I guess it's to the left of the runner, but to the right of that tangent line. Now, if the tangent line looks like this, and it crosses the x-axis like 12 or 13 or 14, some number like that, then you can't see the bear because you can only see everything to the right of that tangent line. So hopefully that makes sense to you. That's the logic that I wanted you guys to do. That's the critical thinking, right? That's the critical thinking that you guys all have. You got to slow down and you just got to think like, well, how do I figure this out? You need a tangent line. So figure out where that tangent line crosses the x-axis. Because that's how vision works, right? You see at a tangent if you're running like this. So I'm gonna find the tangent. So I'm gonna write find tangent at 5, 2. All right, so here we go. Let's find a tangent at 5, 2. I need a dx dt, so I have a point. What do I need? What two things do I need for a tangent line? A point and a slope. So I need dy dx. I need a slope. So I'm going to take my equation, 4x squared. So let's see. And I'm going to try to write small because I have a feeling I might take up most of this. 4x squared plus 25y squared equals 200. All right, so here we go. I'm going to take the derivative with respect to x. The dy dx is always slope. So the derivative of 4x squared with respect to x is just 8x. Plus the derivative of 25y squared is 50y dy dx equals 0. Just like before, I think it's a good idea to just type it in right here. That's just me. Some teachers like to solve for dy dx and then plug in whatever you think is easier, guys. 8 times 5 plus 50 times 2 dy dx equals 0. I don't see any issues. Let's see. 5, 10, 15, 20, 20, 30, 35, 40. So 40 plus 100 dy dx equals 0. I'm going to move the 40 to the right. So 100 dy dx equals, let me make sure I don't have any errors. I think we're good. And then I'm going to divide by 100. So dy dx equals negative 40. That's an equal sign. Over 100, which reduces, right? 20 goes into 40 twice, so negative 2. And then 20 goes into 100 5 times, so negative 2/5. There it is. There's my slope. So my tangent is y minus 2 equals negative 2/5, parenthesis, x minus 5. And you could, if you want, like the only time you cross the x-axis is when y is 0, you can plug it in right now and solve for x. But I don't want to confuse anyone. I'm just going to go ahead and just, distribute this, see what that is. Y minus 2 equals negative 2/5 x plus, negative times a negative is a positive, the 5 cancel out, 2. And then plus 2 plus 2. So here's my tangent line, negative 2/5 x plus 4. Now, where does this tangent line cross the x-axis? Well, whenever you cross the x-axis, guys, the y value is 0. So I'm going to set that equal to 0, negative 2/5 x plus 4. And I'm going to move that to the left. And I guess, like I said, you could have just solved it up here, up there, but no big deal. So here we go. So I have 2/5 x equals 4. And then I'm just going to multiply by the reciprocal. 5 over 2, whatever you do to one side, you do to the other. And then you get x equals, 2 goes into 4 twice, and I get x equals 10. So remember, you can only see numbers bigger than x equals 10, and the bear is at 8. So when I do my tangent line, I can only see everything. So here it is at 10. and I can only see everything to the right of that because the bushes get in the way. So no, since bear is at x equals 8, comma. Let's see. Does she have a name? That's you. You can't see the bear. Period. Parenthesis. You can only see for x greater than 10. All right, there it is, guys. All right, let's keep going. That was a fun problem. I liked it. Why did the dy dx go way up here? Consider the curve given by the equation y cubed minus 3xy equals 2. So hopefully you remember this. This is from a previous exam. I think it might have been a quiz. I don't remember. From a previous exam / quiz. So hopefully it was a freebie for you guys. Consider the given curve. Find the equation. No calculator. So here we go. The derivative of y cubed with respect to x. Because that's what they want. They want to find dy dx. So take derivative with respect to x. So let's see. 3y squared dy dx minus, and if you want, you could do that. Or I saw some of you factor out the 3. Not a big deal. Not a big deal at all. First times root of the second. So 3x times root of the y. So dy dx. Let's see. Plus second y times root of the first, 3. Close it. Equals derivative of 2 is 0. Then just distribute the negative there. 3y squared dy dx minus 3x dy dx minus 3y. So that's the issue. Some of you didn't put that negative there. Equals 0. So it's algebra that's going to hurt you guys. Move the 3y to the right. So 3y squared dy dx. And I know I'm going slow. Some of you I know can already just factor out immediately and just get your solution. But, I want to make sure that everyone gets it. Now I'm going to factor out that dy dx here. So dy dx, factor it out, parenthesis, 3y squared minus 3x, close it, equals 3y. And then your last move is just, see this is a product, dy dx times this. Go ahead and just divide by that 3y squared minus 3x. So dy dx equals 3y over 3y squared minus 3x, which we took. I took that. But you could also factor out a 3 in the denominator. And then you would have y squared minus x, and then those 3's cancel out. Bam, bam. Any of these answers would have been fine. It's not a big deal. This is okay, and this is better. But whatever, not a big deal, guys. And there it is. All right, let's keep going. Write an equation for the line 10 to the curve at the point 1, 2. Use this tangent line to approximate y when x equals 1.3. Okay, so I need a point and a slope because they want a tangent line first. There's my point, and now I need a slope. So dy dx evaluated at 1, 2 equals, and then I'm just using this guy right here. So that's a y value on the top. So all right, 2 over 2 squared, which is 4, minus, and then my x, which is 1. So 2 over 3. I don't see any issues. I think we're okay. Let me make sure. Yeah, I think we're fine. So here we go. My tangent line. Y minus 2 equals 2/3. X minus 1. I think we're good. I don't see... Hold on, guys. My laptop here to my right needs a restart. All right. This is my tangent line, guys. I'm going to go ahead and plug in that 1.3 right here. So let me write f of 1.3 is approximately, let's see, 2/3. 1.3 minus 1 is 0.3. So I'm going to write 0.3 and then plus 2. Now 0.3, guys, is just like saying 3 over 10. That's 0.3. So let's go ahead and do that. So I'm going to write, let's see, equals 2/3 times 3 over 10 plus 2. Let's see, this 3's canceled. Bam, bam. And then 2 over 10, that's just 1/5. 1/5 plus 2. Well, 1/5 is 0.2. 1/5 is 0.2. Be careful there. That'll almost look like a negative there. So that's just going to be 2.2. So f of 1.3 is approximately 2.2. You could have turned that into a fraction if you want. 2 and 1/5. So let's see, 2, 10, 11 over 5. That would have been fine. All right, here we go. Let's go to the next one. It says, find the second derivative. Well, let me zoom out. Here's my first derivative. So let me go ahead and write my first derivative first. Dy dx equals y over y squared minus x. Okay, here we go. So second derivative. I have to use quotient rule. There is no other way. You have to use quotient rule, guys. Bottom, y squared minus x times root of the top, dy dx, minus top, y times root of the bottom, 2y dy dx, minus 1. I'm taking the with respect to x. Let me make sure. Bottom times root of the top, dy dx, minus top, y times root of the bottom, 2y dy dx minus 1. All this is over bottom squared. Okay, I'm done. I'm just going to plug in my 1, 2. We already have what dy dx is at 1, 2. It's 2/3. So here it is. 2 squared, d squared over dx squared equals, let's see, y squared. So 2 squared is 4 minus 1 is 3. So I'm going to have, let's see, I'm going to have 3 times dy dx, which is 2/3. And make sure, I want to make sure that everything's correct. 2 squared 4, 4 minus 1, 3. All right, we got that. Minus my y, which is 2. And then 2 times 2 is 4. So I have 4 times dy dx, which is 2/3. And we'll figure that out right now. Minus 1. And then all that is, let's see, 2 squared, 4 minus 1, 3. 3 squared, 9. I think we're good. So let's see. I'm going to turn this one. So this 4 times 2/3. 4 times 2 is 8. So let me erase this, and I'm going to call this 8/3. And this one, I'm going to go 3 over 3. So 8 minus 3, that is 5/3. So let's see. I'm going to write it as, and these 3's cancel out there. So I have 2 minus, and I still have that 2 there. That 2 is that 2. And then 8 minus 3, that's 5/3. All over 9. Okay. 2 times 5 is 10. So I have a 10 over 3 right here. I have a 10 over 3 right here. So let's see. I have 2 minus 10 over 3 over 9. I'm going to turn that 2. I'm going to multiply it by 3 over 3. So 2 times 3 is 6. So this is 6 over 3. So 6 minus 10 is negative 4. So negative 4 over, and then I have 3 in the denominator, and I have a 9. So 3 over 9, that's 27. And there it is, negative 4 over 27, guys. I don't see any issues. I think we're good. Yay. Let me know if that one gave you issues. All right. Is your approximation in part B an overestimate or an underestimate? Justify your answer. We know enough for this, guys. So this curve, so look what, okay, let's just go right into it. This estimate here, we used it with our tangent line. And I know that at the 0.12, that because my second derivative was negative, that means my original function, the curve, was concave down. If you have a concave down graph, and let's see, what was my slope? Positive. So, and I'm over here on this side of the vertex, and I have a tangent. Think about it, guys. That tangent line is above the curve. See? Because you're concave down. Chop, how do you know you're concave down at the 0.12? Well, I got a negative. So, because my tangent line is above the curve, it is a overestimate. So that's what I'm going to say. Since my second derivative is positive, negative, is negative, comma, curve is concave down. Tangent line lies above curve. What curve am I talking about? I'm talking about this curve. That one right here. Y cubed minus 3xy. Y cubed minus 3xy equals 2. Yep. Tangent line lies above curve, comma, hence, comma, estimate is, approximation is overestimate. Use the stem. Approximation using tangent line is overestimate. And there it is, guys. There it is. That's what I wanted to see. Something like that. Whew. All right. Let's go to this one. I was hoping that we would kill this one because that's the one that I gave you guys on the practice one as well. And I thought I had given you guys a big hint about that we're going to do this one again, but it's fine. Let's just talk about it and see what's up. Let h be the function is a graph consisting of 5 line segments shown in the figure above. Find the slope of the line times the graph of f at x equals pi. So I have a function f, here it is, and that's what I'm going to write. So let me write that down first. F of x equals cosine 2x plus e to the sine x. Okay, here we go. So f prime, so they want the slope of the tangent line at pi, so that means you got to take a derivative. F prime of x equals the derivative of cosine is negative sine, so negative sine 2x times 2 plus the derivative of e to the sine x is itself, e to the sine x times, and then chain rule the derivative of sine x, which is cosine x. I don't see any issues. I guess maybe write it a little prettier. I mean, you don't have to. Negative 2 sine 2x plus cosine x e to the sine x. If you feel compelled, go ahead, not a big deal. F prime of pi equals negative 2 sine 2 pi plus cosine of pi e to the sine pi. So sine of 2 pi on the unit circle, your 2 pi is over here, and that coordinate is 1, 0. Remember that sine is always your y value. So I have negative 2 times 0 plus cosine of pi is over here. That's negative 1, 0. Cosine is the x value. So you're going to have negative 1, and then e to the sine pi, so that's e to the 0 right here. That's e to the 0. And e to the 0 is just 1. So again, you're going to get 0 plus negative 1 times 1, it's a negative 1, plus a negative 1. So f prime of pi is just negative 1. I think we're good. Let me know if something doesn't make sense, guys. All right, letter B. Let k be the function defined by, and then they tell me what is defined. I'm just going to take a derivative. It says find k prime of pi. So k prime of x, so it's just chain rule. So derivative of the outside, leave the inside alone, f of x, times derivative of the inside. There it is. I'm going to plug in a pi. So k prime of pi equals h prime of f of pi times f prime of pi. Okay, so we need f of pi. We don't have that yet, but we will. We'll get it. So here's my f of x. So I'm going to come over here. F of pi equals cosine of 2 pi plus e to the sine pi. So it's just baby pre-count, not extreme, guys. Cosine of 2 pi is 1. And then e to the sine pi again, that's just e to the 0, which is 1 again. So that's 2. So f of pi is 2. So now I have h prime of 2 times f prime of pi. I already have f prime of pi. That's this one right here. But I need h prime of 2. So I come over here to h, and I need to figure out this slope here. So notice I'm at 0, 0 there. The scale's by 1. At 1, 2, 3, and this point right here is 3, negative 1. So I go down 1. Remember, slope is change in y over change in x. So I go down 1, and to the right, 1, 2, 3. So my slope is a negative 1/3. Negative because I'm going down, or I guess left to right, you're decreasing. So there it is. There's my slope, negative 1/3. 1, 1, 2, 3. Yep. So I'm going to write over here, I'm going to write h prime of 2 is a negative 1/3. And now I'm ready. So here we go. So it's right here. So I'm going to write h prime of 2 times f prime of pi equals, and h prime of 2 is a negative 1/3. And then f prime of pi is a negative 1. So 1/3. Okay, let's go to the next one, guys. It's still the same question. Let m be the function defined by, and here it is, and they want m prime of 2. So I'm going to do product rule, a little bit of chain, not too much though. M prime of x equals first times root of the second plus second times root of the first, g prime of negative 2x times negative 2. And I know some of you reverse it. You guys have this in the beginning and then this in the end. That's fine. It's not a big deal. All right, let's plug in a 2. M prime of 2 equals g of negative 4 times h prime of 2 plus h of 2 times g prime of negative 4 times negative 2. All right, so let's get the g of negative 4 from this table here. So g of negative 4 is 5. And then h prime of 2, we already had that number. H prime of 2 is negative 1/3. Plus h of 2, well, we don't know that just yet, but we will. We know that the slope is negative 1/3, so h of 2 has to be a negative 2/3. I don't know why I put parentheses there. Sorry, guys. So negative 2/3. And then g prime of negative 4, well, I have it right here. That's negative 1. And then times negative 2. All right, let's see. Negative 5/3 plus negative times a negative times a negative is still going to be a negative. So negative 4/3. Negative 5 minus 4, that's negative 9. So negative 9/3, which is negative 3. Yay! All right, we're almost done, guys. We're almost done. Is there a number c on the closed interval negative 9 and 3 such that g prime of c is negative 4? Well, I guess first let's do it by intermediate value. So let's see, negative 5 to negative 3. So I'm only looking right here. And let's see, negative 3, negative 1, 4. Nope, I never hit negative 4 with IVT. So we can't use IVT. We can't use IVT to prove this. And I probably shouldn't be abbreviating intermediate value theorem. We got one more theorem, the mean value theorem. So let's see if the mean value theorem, so the mean value theorem states this. G prime of c equals g of, I guess we can go any order we want. Usually I go g of b minus g of a over b minus a, but whatever floats your boat. G of negative 3 minus g of negative 5 over negative 3 minus negative 5. So let's do that. G of negative 3. We're assuming that g is differentiable and continuous, and it is because we have a derivative, right? So g of x is continuous. G of x is continuous since g is differentiable. Hence, we may use mean value theorem. You might be able to get away with not stating that, but it's always better to be safer than sorry. G of negative 3. Let's see what g of negative 3 is. G of negative 3 is 2. So 2. So I'm going to go g prime of c equals 2 minus g of negative 5. G of negative 5 is 10 over negative 3 plus 5. So let's see, negative 8 in the numerator and 2 in the bottom. And OMG, look at that. So I'm going to say, is there a number c on the closed interval such that, so use the stem. Yes, by mean value theorem, comma, there is a number c. There is a number c in the closed interval negative 5 comma negative 3 such that g prime of c will equal negative 4. There it is. And just use the stem of that, and by mean value theorem, yeah, instantaneous rate of change has to equal average rate of change, and I got an average rate of change of negative 4, so there has to be a derivative of some c value between negative 5 and negative 3 where the instantaneous rate of change is equal to the average rate of change. What does that mean in plain English? It just means that there is a tangent line that is parallel to your secant line between negative 5 and negative 3. All right, and then we just do these, and that's it. We're done. Derivative of sine x is cosine x. The derivative of cosine x is a negative sine x. The derivative of tan is secant squared. The derivative of arc sine is 1 over square root of 1 minus x squared. Let's see, the derivative of arc tan is 1 over 1 plus x squared. You could say x squared plus 1, not a big deal. The derivative of e to the x is e to the x. The derivative of secant x is secant x tan x. The derivative of cosecant x is negative cosecant x cotangent x. The derivative of cotangent x is negative cosecant squared x. Anything that starts with letter c, when you take the derivative, is negative. The derivative of ln x is 1 over x. This is an exponential, guys. This is an exponential. The derivative of exponential is itself 3 to the x squared times ln of whatever the base is, ln of 3, times chain rule, the derivative of x squared, times 2x. You could have rewritten it as 3x squared times 2x ln of 3. That's not a big deal. Some of you are multiplying this 3 and 2 and calling them 6. You can't do that, guys. You can't do that. That's not a thing. This is 3 to the power x squared. This is 2x. You can't. You're defying math rules there. The derivative of this is 1 over x ln of 7. There it is. Now you could always do the change of base, guys, the change of base formula. D dx, and then log base 7 of x is the same thing as saying ln of x over ln of 7 from your pre-cal days or maybe your algebra 2 days. So if you were to continue with that logic, you could say 1 over ln of 7 times ln of x. And then 1 over ln of 7, that's just a constant. So the derivative of ln of x, you already have it right here. That's 1 over x. So 1 over ln of 7 times 1 over x, which will get you back to here. All right, there it is, guys. I hope you're happy, and I'll see you guys very, very soon. All right, later. Bye. Oh, Merry Christmas and Happy New Year.